So only the last question we'll discuss, which is related to planning of the experiment. We have a sample of a furniture cleaner containing sodium chloride. It is similar to that of yesterday's experiment, in which we are separating a silica, water, silica is there, sodium carbonate is there. So we have sodium chloride, we have aqueous ammonia, and we have sand. The first question is, give a test to show the presence of ammonia in the mixture. What is a test to check the presence of ammonia? So we can check with the litmus and it will, or red litmus, it will turn. Chlorine bleaches the litmus paper, but if it is ammonia, we can check with the red litmus. It will turn blue. Next, plan an investigation to obtain a sample of pure water from the mixture. So what we want a pure water from the mixture. We have aqueous ammonia and dissolved salt is there. So what we will do, we can use a simple distillation here. And what we do in simple distillation, first we will heat the mixture to form vapors, water vapors, and condense to form a liquid, or use a condenser to remove the energy and form the liquid. And if you want to separate the sand from this mixture, how we can separate sand from the mixture? We can use filtration or decanting, both can be used. So first mention the name of the technique, filtration, and how it is done. Because it's of 3 marks, so use funnel with a filter paper. The sand left as residue, and wash the residue with distilled water and then dry the residue. So this is how we obtain a pure sand from a mixture. Is it clear, discussion? Okay, in this question, calcium carbonate and kaolinite are both white solid, and they're found in sedimentary rocks. Calcium carbonate react with hydrochloric acid to form aqueous calcium chloride, and kaolinite does not react with dilute acids. You are provided with a mixture of calcium carbonate and kaolinite and excess of dilute hydrochloric acid. Plan an experiment to determine the percentage of by mass of calcium carbonate in a mixture. So means you want to find what is the percentage of calcium carbonate, or how much calcium carbonate is there in the mixture. So first what we will do, because to calculate the percentage, we should know the starting mass, initial mass. So first what we do, we will measure the mass of the mixture. The first step, we will measure the mass of mixture by better mention the operators by using a balance. Then add dilute hydrochloric acid by help of measuring cylinder, burette, or a pipette. Until no more bubbles formed. It shows that all of the calcium carbonate is reacted. Then what we will do, we will filter, because the kyanite will not react, so it will remain as a solid. So filter to remove kyanite from the mixture. Then we will dry and reweight. We'll measure the mass again. And after measuring the mass again, what we will do, because what will be the mass of calcium carbonate? The initial mass, the starting mass, minus the mass of kyanite. And then we need a percentage. So you can write a formula for the percentage. So percentage of calcium carbonate in the mixture is equals to mass of calcium carbonate divided by mass of the mixture, the initial mass of the mixture. Multiplied by 100. So this will give you the percentage of calcium carbonate present in this mixture. Is it clear, this experiment? So in this question, cassiterite is naturally occurring form of tin oxide. Describe how you would obtain a sample of a tin from a large lumps of cassiterite in the lab and determine the percentage by mass of a tin present in it. Tin is similar to reactivity of iron. So this gives you an idea that you can use any more reactive metal, or you can use any more, you can also use carbon to separate the oxygen from the tin. So first they give you a hint in the question, like large lumps are there. When you have large lump, so first thing what you should do, you should reduce the size. And how you can reduce the size? By the apparatus which you will use, so we will crush the lumps by mortar and pestle. That is first thing. Then we will weigh cassiterite by balance, because we have to find the percentage of the tin present in this tin oxide. Now we have to remove, so heat and reduce by carbon or carbon monoxide Basically what happened, like you have tin oxide. If you use carbon monoxide, which is a good reducing agent, so it will remove oxygen from the tin, and the tin is separated, the carbon dioxide gas will escape. Then measure the mass of tin left after complete reaction. Then we need a percentage of the tin present in this ore. So percentage of the tin is equals to mass of tin divided by initial mass of cassiterite and multiplied by 100. So this is a 6-mark question from paper 6, variant 3 of May June 17th. Is it clear? Discussion. This one is October, November 2017, paper 6, variant 1. Iron, tin, zinc all react with dilute acid to produce hydrogen. Plan an experiment to determine the order of the reactivity for iron, tin, and zinc, and you're provided with a powdered sample. So here we already have a powdered, so we don't have to crush. If you mention mortar, pestle, crush, then it is not having any marks here. And a common lab apparatus. So what we can do if we want to identify, so we can measure the rate of the reaction. When metal is reacting with acid, so it is giving hydrogen gas. So we will take, for example, 10 cm cube of acid, hydrochloric acid. Then add 2 grams or add equal masses each element to acid. Then measure the volume of the gas by gas syringe. Then record the time by stopwatch. Then measure the volume of a gas, record the time by using a stopwatch, then compare the volume of gas for same time interval, like it should be like in 3 minutes, 2 minutes, which gives a greater volume of a gas. So compare volume of a gas for the same time interval. And the experiment in which greater volume of gas has the fastest rate Is it clear? You can also write a formula for the rate. That is also the part for this question. Is it clear, this experiment in which we plan to compare the rate or the speed of the reaction? Iron nail rust, the mass of the nail increases. Plan an experiment to investigate if the iron nail rusts more quickly in a tap water or distilled water. So what we will do, you are provided with the new iron nails and common lab apparatus is there. So we'll measure 10 cm or take 10 cm cube of tap.
So what's the difference between tap and distill?
Distilled water, tap water contain more dissolved impurities compared to distilled water. Tap water may
Distill,
have distilled water having a pH 7. Tap water may have, because of dissolved impurities, it may be alkaline, it may be acidic.
so we can say that distilled water is pure.
Yes, you can, like comparison. No, you can mention that as well.
Okay.
So the idea is that because the tap water is running through the or moving through the pipeline, so when it is moving through, it is dissolving different substances in it. So take 10 cm cube of tap water and distilled water. Transfer to test tube. After transferring this to test tube, take equal or equal number of iron nails by balance. Then leave the apparatus because rusting is a slow process for 1 week. Then we will filter and reweight again. Then we will dry also. Then compare the final mass with the initial mass. Experiment which show greater change in the mass, means the initial mass is same for both, but the final mass is higher. So experiment which show a greater change in mass has or rust has the fastest rate. Is it clear? You can add on, like you can write more things. I'm just explaining the idea to write the experiment.